Hello, everyone. I actually don't work for AWS. I work for you guys. It's great to be here, and of course, that Amazon pays me, but my job is to help you guys be successful. And for that, we need to talk. I need to have a conversation with you and understand where we are. Is anybody here using infrastructure as code at all? Like, you, gent, could you please say what you use in infrastructure as code? Okay. Let's start with infrastructure as code. We'll get to Amazon right there. And someone else, infrastructure as code, using, deploying, like real coding stuff. You? Yeah, I'm using Terraform from HashiCorp. We just heard some great stuff about that. But most importantly, why? Why are we doing this? Why are you using infrastructure as code in your company?
Because I want to reproduce I want to reproduce my infrastructure maybe in another like in some other place, or I want to change my infrastructure. I want to have state of my infrastructure and do some changes on it.
Perfect.
And yeah.
Perfect, thanks. Any other reason to use infrastructure as code that comes to your mind? Reproducing environments is his case. Anybody's got another idea? You can shout it out, no problem. Sorry, I heard one here. Automation. Automation for what kind of business purpose would that serve?
Automation to avoid the problems, the errors when creating manual things.
Yeah, like manual things are error-prone, right? And this is a couple examples, and everybody that does infrastructure as code does it for a bit of different regions. And I'd love to hear more about your experiences and why do you use it, but I'll start showing about things back home at Amazon. And you guys probably, everybody know Amazon, and this is Amazon like 2008, 10 years ago. And this, I believe, was like when Obama was first elected. Like, it's hard to remember what happened 10 years ago, but we had smart watches and keyboards on cell phones and things like this. And this is what was on the back end of that. So we already had that Death Star of microservices and loosely coupled, fine-grained software components everywhere in this architecture backing up this website. And this ended up being important not only for Amazon, but for a lot of people. At Amazon, the way it happened was that Jeff Bezos suddenly came to the company one Monday and said that from that point on, every team would be organized in two pizza teams, like teams that can be fed with two pizzas. Okay, that American pizzas can be quite a lot of people, but usually it would be teams of 10 to 15 people. And here's the rule: nobody can touch each other's database. They have to go through a service interface, and that's it. And that led to this decoupled development of things. And in other companies, it happens just the same way. For example, this is Netflix. By Adrian Cockcroft. He's now with us at Open Source Amazon. And Twitter and Halo and many other companies ended up doing the same because it's actually the only way to grow and scale engineering. Like, if you have so many communications paths and dependencies and trying to do this tightly coupled, it gets to a point where you end up with this huge thing that hardly moves and barely anyone understands. So getting it into this decomposed, granular approach is something that it may not be your case right now, or you may be headed there, or maybe just interested, but it is a heavy trend in scaling not only software, but scaling the organization as well. And to do this, you need to build things as code, right? You can't just and a lot of people are behind this idea. The whole thing is, when you're deploying at this speed and running those so individualized teams at Amazon in 2014, we had an average of one deployment every second and a half, 15 million per year and things like this. This gets impossible to do by hand, right? You can't be this guy trying to find where things connect and where to deploy stuff. You want to be on this continuous delivery scenario and just keep things running, right? And automated and repeatable and secure and all these things that we were talking about. So Amazon got its own services and customer demands and turned that into publicly offered services, as it did for many others. So I'll show you guys a bit of that right now. We have here under, this is the AWS console that probably most of you are familiar. And here we have this suite of tools called the developer tools. I will start with those. One in specific called CodeStar. And CodeStar is a project generator. I can start a project here, and we have all sorts of languages and backends. You could do Go, Node, Python, static websites. You could go either serverless with AWS Lambda or server full with Beanstalk, EC2, and these kinds of services. So I'll pick here Java, Web, and Beanstalk because that's really common, but we could do like any other of those technology stacks. The process would be very, very similar. Just to show you what's behind and some technologies that we offer to help with this continuous delivery thing. So demo DevOps BCN should work. And here I have two options to store my source code. I can do GitHub, of course. Who wouldn't love open source software? Well, if you can't, if you must use your own repo private in your company behind your firewall, we have code commit for that as well. So it's up to you if you want to do open source on GitHub or private source on code commit. I'll use GitHub today and connect with that. Connecting to other to code commit would be just the same. And this will create the project there and create all the steps in the pipeline for building, testing, deploying, and monitoring the code. One example, the usual key pair. I'll take this one and create the project. And I have one of those set up already. It takes a couple minutes before it creates the code, pushes to GitHub, and deploys everything. So I have one of those pre-baked, I believe, in the Ireland region, if I'm not wrong. Yeah, here's what it will look like after it's complete. And the cool part is this pipeline here now. We can edit this pipeline and see what it generated for me. So it's going to fetch the source from our GitHub, run the build in code build, and run Elastic Beanstalk application deployment. And here we could add stages and steps to fetch the sources or build or do anything that I want from other stacks, other technologies. I could deploy with CloudFormation, with Code Deploy, with Terraform, with lots of different tools, and add like human approvals or customize the software delivery process any way I want. This is just an initial schema. And just showing you guys a bit of the components. The code pipeline is just this orchestrator, just this workflow. And code build is the one that's actually going to do the building. And this is the repo for this app. And in this build spec.yaml file, you can see the declarations that made the code build work So this is just what code build is going to do. It's going to fetch your repo, interpret this file, and the first time it happens, it's going to run this install command and run this pip install. Then it's going, before the build, run a clean compile and test, then generate the exploded war file, and whatever steps are necessary to generate the artifacts that are going to be placed in this. And it's going to be automatically uploaded to S3 and then deployed by the next step. So code build is the build part of your process. In some tools, this is the same thing, the workflow and the build. Here is different. Code pipeline orchestrates the whole thing because for some languages and stacks, you may not even have a build phase at all. You may just want to throw your JavaScript somewhere. But if you do, you can build with code build, and it will be automatically published. And when that's done, any change will be reflected in your application's endpoints. Mine is running here, and I can see that the web app running. If we were to change the file and push it, you would see it automatically coming forth through production. And that's the first idea that I'd like to share. So this is not something really complicated as it used to be. You can spin up a continuous delivery pipeline, and as I just did here with you guys. And so this is CodeStar, and code pipeline and code build, and this is the overall management tools that we have for doing this part of the job. The actual runtime can be a bit different. In this example, I used Beanstalk. And although there's a lot of discussion about containers and serverless and Lambda, this is one that's your old the package deployment style. You can select your package, select your environment, deploy this environment with this package, and change configurations, clone environments, and do most of the DevOps tasks that you would have to write a script. It's probably already in Beanstalk, right? So it's like the most managed DevOps we could get. But it's also a very customizable tool. Something that little people know about Beanstalk is it's actually on top of CloudFormation and on top of this whole stack. So if you have this, the whole secret is this EB extensions. So if you declare inside this EB extensions directory this .config files, you can customize your environment with anything you want. You could add DynamoDB tables. Here's a sample DynamoDB tables, CloudWatch alarms, and any kind of AWS resource that you would like to add. You can build your architecture having caches, Elasticsearch, and whatever services are important for you, all declared in this file, and just deploy and manage with the very simple tools that I just mentioned. And that's the bread and butter, and probably everybody does this a bit differently. I just would like to share the AWS native way tools and services to do this. And now let's focus on some specific parts on how to do it well and make it well architected and compliant with our requirements. And first is reliability. So how do we make sure that changes go smoothly to production? And the first thing the first important idea is not making changes in place, because when you have these complex architectures with things referencing each other, and you change one in the middle, such as deploying a package or changing a configuration, is really, really risky and where things usually go wrong. And when they do, it's hard to roll back. So undeploys not actually, sometimes don't work. Sometimes you have to revert many changes at the same time, and it gets really complex. So the whole idea is doing it blue-green, where instead of changing one environment, you spin a new one, run your tests. When it's stable and ready, you shift traffic instead of changing things in place. Because with EC2 instances, you pay by the second, and so you scale one up, scale the other down. The difference, of course, there is one extra cost where you have resources in both at the same time, but if it's the same amount of traffic, it should cost about the same amount of money, right? And again, in those tools, this is automated for you already. So in Beanstalk, we have the swap environment URLs that does just that. Change the name of environment E to the name of environment B, and one will gradually lose users, and the other one will gain users as the DNS changes propagate over the internet. Of course, there is many ways. There are different ways to do it. There are microservices platforms such as Netflix's that does this a bit differently, but DNS is one simple way to solve this, and here's it in Beanstalk, right? And another extension of this idea is reducing the risk by rolling this very slowly and to only a small subset of the users. So, for example, you could change only the beta or the preview users to the new environment and have it running for a while, or half the users, or it depends a bit on your application architecture if you want to do half and half, thirds, or double, and then nothing. And, because it depends on how many environments you keep and if you're multi-tenant or not and things like this. But that's the whole idea. Take a few servers, throw some traffic at them, and I see two different types of canary release. There is people that turns live traffic to a small amount of servers, and there's people who creates a fork in traffic, so every request goes to two different ways, and just ship a copy of the traffic to a different environment and make sure it is stable before releasing the new version, right? And that's the whole idea. And of course, remembering that releasing a release and a deployment are very different things. You can deploy software all day long and not release anything and just turn on that feature flag when you need it and make it available to public so that it's not stressful to engineers when a new release is going on. And that's the true value of feature flags. And with this, you're probably going to have not one, but multiple production environments. For example, you could have not only red, green with version N and the next version, but you can extend the same idea to have three production environments, 4 production environments, or even more. For example, if you're running e-commerce, you could ship 5 different pages, landing pages for your website, and see what has better conversion in terms of click-through rate or advertisement or whatever are your business metrics, and route traffic to the things that does better. Or the same for performance, or whatever kind of business criteria that you use to select releases, you could do it at the same time using this idea. And just to show the impact of resiliency, this is how Netflix does this. And they have this army, Simian Army is a project to randomly kill instances. Like the chaos monkey just kills instances randomly. It's a set of scripts. And there is one called Chaos Gorilla that takes out an entire availability zone. And there's one called Chaos Kong that kills an entire region. And you don't even know about it. You can keep watching Netflix as if nothing happened, because under the hoods, that's the kind of thing they do. So this is a simulation of traffic going around. And Netflix has right now above 35% of US internet consumption. So every little dot is like gigs and gigs of traffic. And you can see this error rate here coming up. And as they detect, this is probably a bug, for example, they redirect traffic to the other regions. They're in 3 regions in the US. And again, when it's completely separated and isolated, you will see the redeployment going on and traffic coming back without any changes, right? Any problem to users and things like this. So they can just shut it down and spin a new one and come back to service due to this very effective health management and health pinging that they have. And the one important part to make this true and have it happening for real is this database part, because the data is the really hard part here, because you're not shifting data around, right? You can spin up app servers, cache servers, whatever servers you want, but when it comes to databases, you're not moving terabytes and terabytes of data around every deployment, right? I surely hope not, because this may be really, really slow and expensive. So I see it's more common to use data management techniques and data solutions that are more flexible and scalable than your usual relational database. So we see these patterns such as separating the command side of things to write things and the query side of things to read things faster. And perhaps those can be isolated. Perhaps during a failover, you can query things but not write things, and you can manage your data in a more interesting fashion. And we have a few features to help with this. Amazon DynamoDB has one thing now called global tables, and you can have one table replicated all around the world. And of course, this is one way to do it. You could use Cassandra, for example, that has local and distributed replication, cross-data center replication to achieve this kind of global data and having data always available. Because if you figure out this data part, the service part is not really that hard. But one thing that comes up in the service part is multi-tenancy. Because if you have like 10 customers and separated environments per customer and 5 services and blue-green, and you will end up having to manage a lot of environments, and this can get pretty hard, especially because some of these environments may drift in configuration, some may require custom code, some may have legacy apps and things like this. So one way how to deal with this stuff, how to deal with this packaging and differences in apps is a bit hard. I mean, we have tools for that. And most tools, ours or not, will separate provisioning, configuration, and deployment as being 3 very different things. And you can certainly work that way, but I see a lot of customers succeeding with immutable servers. And probably everybody who's using Docker, and most of you already know this, the idea is instead of having separate provisioning, configuration, and deployment steps, you do it only once. When the machine turns on, it comes up already configured and with the latest version of your software deployed, and it lives like that forever or as long as it lasts. And instead of changing that thing whenever you need it, you turn it up and start a new one, or turn it down, start a new one as you need, right? And this is really popular and implemented in a lot of tools, and notably Docker, right? And Docker is really successful at this, and it's really important to make changes portable to others' environments, and you can run it at home, you can run it on premises, you can make sure nothing drifts. If you have a bug, you can fetch the older image from your image version, latest old version, and reproduce and audit things quite easily. And there is a lot of support for that at AWS. We have a service called Elastic Container Service. So we run containers for you. This is our way of getting your container, putting it into production, integrated with all the services, with all rescaling, integrated with load balancer, integrated with logging, and everything you need to operate containers. And this is really a full-featured platform. Recently, we announced one thing called Fargate. And the difference of Fargate is that you can now manage containers without managing the EC2 instances. Because when you work with containers, you have two layers. You have your instances being your horsepower of compute, where you can run any amount of instances and pack any amount of containers, and the container side of things. So you need to scale both. You may need to scale the horsepower, or you may have enough horsepower and just scale on the containers up and down. Make sense? With Fargate, you don't care about the bottom layer of compute horsepower. You just say how much CPU and memory you want your container to have, and we'll run it for you, and you only pay for those resources. So but it's still on the same managed layer. It's still on the ECS containers. If you want to manage, it's still going to run on ECS using the ECS commands and things like that. And although this is okay, as containers are very portable, some customers want to use the same tools that they use on premises. So we have now Elastic Container Service for Kubernetes. Now you can use the same Kubernetes set of tools, kops, kubectl, and everything that you may have already in your on-premises environment or on other clouds, and run it on AWS. This is on preview right now, but it's coming available in the next few months. But just to make sure that everybody understands the idea here, we do have a lot of other services. We have services for databases, caching, batch compute, event-driven compute, content distribution, and things like this. And I don't think it's probably not a good idea to recreate those services into containers. For example, if you want to run a relational database, I think it's probably more valuable to just spin up an RDS database, and it already comes up with synchronous replication, failover, and all the tuning that is expected for this relational data, instead of you having to create your own container, primary container, secondary container, read replicas, and create this whole architecture yourself. Not to mention that you lose the great things that Amazon has done on your behalf there. For example, we have a service called Aurora that really changes what MySQL and Postgres can do, and it's all behind RDS. You don't lose compatibility because it's the same MySQL and Postgres protocols that you would use. It's just a thing that you don't need to spend this time creating containers for a thing that already exists, but only create the containers for your application and resources. I think that is my idea and the idea that I see a lot of customers using. Of course that we have exceptions. There is people that, well, I want to be 100% portable, I want to do everything on my own containers, and you certainly can, right? I'm just showing you the more usual design. And the tool to help to code this is actually CloudFormation. So CloudFormation is the tool that you can declare in a file all the resources, AWS, distributions, all the other services, plus your application containers and resources. So this is one example of a JSON file, and here what we can see is that in this resources section, I have one EC2 instance declared here with its properties, one security group, outputs. I can have this whole architecture laid down. If you don't like JSON, we have the YAML flavor of this as well. And you declare your image properties and everything that you need. Just the same idea in a different language, one that supports comments. That's quite helpful. And that's how we build things with CloudFormation. When you tell Amazon to create that stack, it will create everything for you. If you delete it, it deletes everything. And all operations are atomic. Everything happens or nothing happens. You're not left in a drifting state and things like this. and a lot more features of CloudFormation. But I'd like to focus on service decomposition, because when you have that many services and that amount of infrastructure as code, you don't want to have one long strip of code with everything. So you've got to decompose that somehow. And you have to bind this to the life cycle of these dependencies. So here's how it's done on CloudFormation. Every tool will do this a bit differently. But one thing is to have cross-stack references. Cross-stack references are when the resources are not in a bound life cycle, when one can be started and created regardless of the other. For example, if you spin up a network with your network design and you create your application design to go on top of that, you may want to delete the application but keep the network available because other applications may be running on that. Or if you have a database or a message queue that serves many applications, it's just a reference. You can delete one while keeping the other. And the nested stacks is through composition. The other one is like an aggregation, if you're talking in design terms. And nested stacks will be a bound life cycle. So in this case, when you delete the parent resource, it will delete the child resources as well. So you could have, for example, application stack, database stack, network stack, and all composed in your own microservice, and the life cycle of these things goes together. So that's something very useful to have, references that have bound and unbound life cycle. And this is how it is in CloudFormation. And I hope other tools have different ways of doing this. Again, here is the cross-stack references is just a reference with this export name. This exports this name. This imports this name, so pretty easy. And here, when your application resource, one CloudFormation stack can reference another CloudFormation stack. That would be this and this ones, and they would be bound in their life cycle. And this is just for a review if you get the material later with these points I've told you about. A couple more features of CloudFormation that may be interesting. We have this command, and everything works from the command line as well. So this is the CloudFormation command line. And it has this template URL property that can point to a local file, and it automatically uploads the template and the builds to S3 for you when you run the CloudFormation package. And this helps a bit when automating this stuff. And there's a lot more you can do. Like, if you see the list of CloudFormation resource types, there are a couple ones that are very interesting. For example, there is this custom resource where you can build anything you'd like. You can build your own CloudFormation module to create any other thing that maybe AWS didn't build yet. Or it's your own part of the stack, and it can be just added with custom resources. And all the things that I told you about in terms of pipelines and applications and deployment, this is also available as CloudFormation templates. So you can create your deployment pipeline using infrastructure as code. So it's like infrastructure as code that you can code to someone else. It may be useful for scenarios when you have many different customers that depend on your pipeline, and when you release a change, you want to release to everybody and have many pipelines. But this is usually a lot for many people. When you get on this, who deploys the deployment of the deployment, or who codes infrastructure as code, now it's the time that most people think they have a customer waiting, and this is a bit too much, but it's good to know that it's there. And just a bit about security and compliance. We heard a bit about today's in the Skyscanner presentation. The We have just announced a secrets manager service, so you don't need to rotate keys and manage secrets anymore. They're saved and stored and rotated automatically behind the scenes, and you can connect this to your databases automatically or fetch the secrets with code, and it just works. So that's the one very easy way. Everything's encrypted, in transit, and at rest, compliant with all the AWS compliance, and things like this. We have a service called Config Rules, and what Config Rules does is watch your changes and the configuration of every resource on your AWS account and audit for that. So you can not only see what changed, configuration changes happened to each of your AWS resources, but you can create rules. And these rules are actually Lambda functions that you can code yourself, or use predefined rules. So you could do things like, if a disk is not encrypted, give me an audit alert. If this instance has port 22 open, fire a compliance alert. And so you can automatically detect compliance problems and security issues with config rules. And this is pretty useful if you're under any kind of audit. And also, we have this very useful thing called tags, where you can classify your environments by anything you want. So you can say that this environment is production, the service is the others, the customer is Acme, or anything at all you want. And using those tags, you can afterwards create security rules and code logic and use these tags into your management. So when you actually build these operations, you can build per tag or report per tag and do everything per tag instead of doing per everything. Another very useful tool we have is CloudTrail. CloudTrail will log every API call you make to AWS. And again, you have the option to bind that to a Lambda function or to a message queue and some other resources, so you know everything that's going on. So for example, if you see a root login, someone logging in with the root account, that may be something that you don't want to happen, and notify and operate. So this is the same idea that we've seen in other talks of automating security into the pipeline. So as changes happens to resources and leaves trails and configuration changes, it's not like if someone puts in a compromised dependency or do any kind of security blunder, you want that to be automatically notified and reported, and we have a lot of tools for that. And not only in deployment time, but in runtime, because some of these things take a while to monitor. For example, say that somebody committed, I don't know, Bitcoin mining. It do not show immediately. It may take a while to pick up, right? On that blockchain. So but you will see some things on your network logs, but it may be a bit hard to process. So we have this tool called AWS Macy, and Macy will look into your data. Right now it supports S3, but other data sources are coming, and classify your data and say what's like risky data, such as secrets, what is not so much a problem, what is personally identifiable information, what is regular comments, and of course that you can help it to classify your data. But the whole thing is, like, if you have one customer representative accessing the data of one customer, that's probably okay. But if you have someone accessing all customer data, it may be someone doing something funky with that data, right? So it's very hard to determine beforehand with rules what this data, what data access is legit or malicious. And this tool just monitors the access patterns to this data and reports if it finds unusual behaviors. So that's like an automated guard for this data. And the whole thing here is making clear that it is possible to be secure and fast at the same time. You just have to have this safety net of security tools in your development pipeline, in your monitoring process, in the logs, and even using AI to help you build this kind of knowledge and be aware when strange things happen. One customer that does this very interesting is Wiley, a very traditional publishing company. And they use this service called Service Catalog. And Service Catalog is a way for you to standardize CloudFormation templates on your company. So if you have internal services that you deliver to other departments and things like this, you can build this catalog of solutions that are already CloudFormation templates and vend them inside your content consistently and making sure that it's correct and available anytime and under the rules that you specify and leveraging of that. And this can greatly improve the speed of enterprise IT. Just to show you one of the possibilities that this kind of infrastructure as code approach lets you do, makes it possible to do this kind of thing, right? And I've written a white paper on infrastructure as code with a lot more words that we could fit in this presentation. And if you'd like to take a look at that, I would be happy to dive deeper. Also, we are doing like live coding sessions on Twitch. So if you want to build stuff together, we are there. And I would love to hear what you guys think and what you guys would like to build so we can build it together and make something interesting, right? And thank you so much. This is me on Twitter. Okay. Thank you. Thank you. And I have all of that. If you have any questions or anything specific that you'd like to see, I would love to show any of that or any questions at all. All right. Huh?
Hi.
Hello.
Thank you for your talk. Do you have any timeline for Fargate to be available on different regions?
Yeah, unfortunately, I don't have timelines. It's something that I cannot. I don't even know, and we don't share timelines. Sorry.
So the same will apply to EKS, I guess.
Yeah. Timelines is. I can say that soon, but that's all I can say. Sorry about that.
Okay, thank you.